Okay, so for this problem, it's asking us to find a polynomial with leading coefficients of 1, degree 5, zeros of I and 5I, and passes through the origin. All right, so let's write down what we know and see what we need to do to get what it's asking us to find. So starting this off, we're going to say we know it's a polynomial, and notice they're telling us to make sure we use p of x. So let's follow those instructions and say it's a polynomial, p of x. Now we're going to start by writing this in factored form. We know we need to have a 0 of I. So because of that, I always know my imaginary roots come in complex conjugates. So I'm going to have x minus I, but then I also have to have x plus I. I have to have the complex conjugate. Now, for the second root, the 5 minus I, remember, it's always minus our root. So if we're going to have 5 minus I, that will give us 5 minus I. Then our complex conjugate, there we go, would be x minus 5 plus I. And that will give us our complex conjugate on that. Then we also know it's going to be passing through the origin. So what does that mean? Well, if it's passing through the origin, that is code. That is sneaky talk for an x-intercept without telling us we have an x-intercept or a 0. So it's telling us that we have an intercept at 0. So you could write it as x minus 0, but that would be a little redundant or a little not needed, so we're just going to write x. Now, it also says that it needs to be degree 5. So what degree do we have? We have x to the first, so there's 1, 2, 3, 4, 5. Perfect. All right, we have the perfect number of x's, nothing else to be looking for. So are we done? We wrote it in factored form. Let's see, does it tell us that we have to write it in standard form and multiply it all the way through? No, it does not. So this would technically be okay, except it does say simplify your answer so that it has only real numbers as coefficients. And right now, we have imaginary numbers. So we are going to need to multiply through a little bit. So I'm going to go ahead and multiply through my complex conjugates because that is the reason we first, or one of the benefits we found when we learned about complex conjugates is that when you multiply them through, we're going to have x I and then minus xi. Those imaginary terms are all going to simplify, right? So that would be the first one. And then multiplying through our next one, I'll do this one in blue to help keep track. So that's going to multiply that, that's going to multiply that. And then I'm going to think of this as a blob. That blob's going to multiply x, and that blob's going to multiply that. All right, so what would we end up with here? The x times x makes x squared minus x times 5 plus I. And then the next one will be minus x times, whoops, I'm getting myself off just a little bit. Let's see, you had x squared negative x times, yeah, there we go. And then the other one will be minus x times 5 minus I. There we are. And then last but not least, this one is going to be, it's a negative, so it's going to make a positive. 5 minus I times 5 plus I. And then this whole thing will be times x, that x on the outside. So just to help you understand, make sure you're following where everything came from. These two factors gave me this. These two factors gave me this whole thing. And then last but not least, my x is still my x. Okay, now let's simplify. Let's just keep simplifying. Okay, so working through. Here, we're going to see this x squared does not simplify, but this xi and minus xi, those subtract to make 0. And then here, we know this is I times I squared, negative I squared, and I squared is negative 1. So that takes care of that. So here's following along, that's just the yellow. Now let's get working on simplifying the green. This might take us a couple steps, but that's okay. First thing I'm going to do is distribute. So this is going to be x squared minus 5x minus xi, or ix, doesn't matter. Now I'm going to distribute this one. So this will give me minus 5x plus xi, or ix. Just to be consistent, I'll write xi. And then over here, we're going to distribute all of this through. So this is going to give me plus 25 plus 5i minus 5i minus I squared. And then this whole thing again will be times x. So this is all still my green. It's getting big. It's about to get smaller though, so that'll be good. All right, and then that's my purple. All right, so finishing off here, and the yellow here, the negative negative makes a positive, so we're left with x squared plus 1 times. Now, let's combine like terms. There's no other x squared terms, so that x squared is going to stay. Here I have a negative 5x and a negative 5x, so those two things together would make negative 10x, right? Okay, let's keep moving here. Now I have a negative xi and a positive xi, so those subtract to make 0. And then last but not least, I have a plus 25. Then over here, I have a 5i minus 5i, so this subtract to make 0. And then just like we saw over from here, what we already figured out is negative I squared. That's the same thing as negative, and then the I squared is the same thing as negative 1. And there we are. So we're going to see the same little repeat. So that negative and negative right here is the same thing as we got going right there. So that's okay. We're almost done. So it just for color coding, that's the yellow. This is still the green. And last but not least, that is still the purple. All right. And let's just do a tiny bit more cleanup, just because it would bother me as a math teacher if we didn't. Let's see, minus 10x. Now, this is going to be plus 25 plus 1 times x, because the negative and negative make a positive, giving me this. And now, I mean, we just have to. We have to, because we have 25 plus 1. I think, hopefully at this point, you're so proud of yourself that you've gotten this far in the problem that you just have to write that as 26 times x. And now we ask ourselves, have we completed what the problem asked us to do? Did we? Oh, and for color coding, just to make it pretty. Just to make it pretty. There we go. All right. So now we have to ask ourselves, did we do what the problem asked? Right now, do we have any imaginary numbers left in our problem? And the answer is no, right? They're all real numbers. They're all real coefficients. So therefore, we are done. It's in factored form versus standard form, but that's okay. You don't have to multiply everything through unless there's a reason to multiply everything through, such as the problem asks you to multiply everything through and put it in standard form. So I hope this video helps.